All right, what is going on, guys? So today I want to go through and do a full breakdown of a Fiber app that's using MongoDB from developing it to taking it to production. So I've written the app ahead of time, and the reason I did that is because I think it's better to, instead of just like recording me actually writing it, I think it's better to take the finished product and then break down piece by piece. I found personally that the best way I've found to learn this stuff is to go through something that's already built and then go piece by piece and try and understand what each of those pieces are. If I just kind of put it out on screen as I go, it's kind of hard to get the full context of why everything's there. So what I'm going to do is I'm going to go through and I'm going to break down each individual piece, tell you why I did what I did, show you how it works, and then we are going to go and host it in Railway. So whole thing shouldn't take that long, and let me know if this is helpful for you. Hey guys, real quick before we get into this, please do me a favor and hit the sub button. I'm trying to hit 1,000 by the end of November. We're very close. There will be something new every single day through November 30th, so it's free, it's easy, do it. All right, so getting started, I have the project open here, so let's go ahead and just demo how this works. We're gonna do go run main.go. And when we run this, we're going to get a Fiber app exposed on 8080. If I go to localhost 8080 and I just do a, let's just start with getting all of the books. So currently there's nothing in the database. So what I'm going to do is I'm going to make a post request here. So then this will post this. It will make a new book. So we'll do just test book. We hit this. It's inserted with this ID. We go back to the get. We now have data in our collection. We can go ahead and add this ID right here. We can get the data back, get a specific book. Then if we want to go ahead and update this, we can make a put request to this, and then let's say test book updated. We send this back, it matched 1, updated 1, and then we go back, make another get request. We can see that this has now been updated. Finally, we can go ahead and delete it right here. We go back to our get request, get all of our books, and it's empty. So just like that, we have a full CRUD implementation working on MongoDB and Fiber. So let's go ahead and break down how this actually works. So starting with main, the way I like to structure my applications, particularly in Go, is Go has a weird way of error handling, and it's typically where you just check whether or not the error returned from a function is nil. If it's nil, you do nothing, but if it's not, then you handle the error. So what I like to do is I like to pass the errors all the way up to this main function where I can have a central way of handling this error. For the sake of this demo, I just panic the error. If we have something that's thrown anywhere, it'll just throw its way all the way back up to main, and then I'll panic right here. But I have one central place to catch those errors. So what I'm doing is I made this run function, which will return an error. So I call run, and then inside of run, this is where the real logic starts. So the first thing we need to do is we need to initialize our environment variables. For this application, we're going to be utilizing a MongoDB database for our backend, so we need a way to connect to that, and to do that, we need a connection string. And this connection string, we can't store that hard-coded into our data. We can't hard code the connection string into our app because, well, A, that's insecure. B, we need to be able to change it based on our environment. On the database I connect to on my computer is going to be different than the database that I connect to when we put it up in production. So we want to make that an environment variable so that we can switch it based on where we are. Then the next thing we need to do once we've loaded those environment variables is we need to initialize our database. Then after we've initialized our database, we need to defer closing it so that when the application shuts down, we'll close our connection to the database before we shut it down. So before this function terminates, so the defer keyword, what that means is that it will execute it'll execute whatever function you pass after defer when this function has returned. So whenever we return something from run, it will then close the database. So let's look at what each of these three functions do. So I made this common directory. You can organize this however you want. That's one thing that's kind of interesting about Go and Fiber and all these frameworks is they're very unopinionated. There are a million ways that you could have actually written and organized this app. I'm just going to show you the way I like to do it and the patterns that personally I find to be useful. So the first thing I have is this common directory. Within this common directory, I have a database file. So the db.go, what this is going to do is this is first going to store an instance variable of my database. So this is going to be my pointer to the database that I need to persist throughout the entire time. Remember, this is not going to be executed in a serverless environment. This is going to be executed in a normal Railway environment. So this pointer is going to persist throughout the entire lifetime. We're going to spin up the server, and then this pointer is going to persist after we call this initialize database function, which within this initDB function, we're going to just be getting the environment variable of our URI, and then we just run the basic connection stuff. If you want to get more information on this, the quick start in the MongoDB Go documentation has a great breakdown of this, but essentially all we're doing is we're just doing mongo.connect, and then we're passing in our URI and then passing it out. And if you remember, along the way, we're handling all these errors, so we're doing returning the error if we get that. And you'll see right here, actually, I didn't do this right because I just copy pasted this out of the docs because I didn't, you don't know this off the top. there's no reason to memorize any of this stuff off the top of your head. Use documentation, it's there for a reason. So here I'm doing log.fatal, and that's actually an anti-pattern for what I'm currently doing, because then I would be terminating the application with an error right here. Instead, I want to just I want to throw a new error up to the end. So what I'm going to do is, okay, so what I want to do right here is I want to return a new error. So I'm going to do return errors.new, and then inside here, I'm going to put in, I'll just let it fill out this, which is what Copilot's saying. I agree with that. So we're just going to pass in that information, and then there we go. So now this is getting thrown up. Okay, so now this is going to get thrown up, so then all of our errors will be handled at that top level. So now that we've done this, we can go ahead and initialize our client, throw the error up if we need to, then we set our database pointer to be pointing to our client.database. Here, I'm just going to call it go_demo. So we have to remember that when we set that up in Railway later, and then we return nil because if we got to this point, there was no error. Now, the next function we have is the close DB. All this is doing is just db.client.disconnect, so I'm just disconnecting the database, very simple. Yeah, so we just disconnect our database here. Then now that we've done all of this, we can go ahead and take a look at our env. So all this is going to do is this is just going to check whether or not we're in a production environment or a local environment. So I'm using this package called go.env. So this is going to load .env files if we have them, but I don't want this to be running in production because I just want to use regular environments there, but I do want to be able to load a .env file in the localhost. So whenever I'm running it locally, I want a .env file, but I don't want it in prod. So I just check, I make this little environment variable for myself of prod. So in localhost, that's going to be not set to anything, so it'll just return an empty string. So I can just check if prod is not equal to true, which it will be on my computer here. It'll just load the environment variables, and then if there's an error, it'll return it. Otherwise, we return null. So those two kind of just initialize the backbone of the project. We get our database and environment variables set up. Then if we go back to here, we can start initializing the actual app. So the first thing we get is we just initialize our new Fiber app. If you're familiar with Express.js, this is almost the exact same thing. You just create a new instance of the app. Then we can add whatever we want to it. So the next thing I'm going to do is add some basic middlewares. The first one is a logger. So this logger will just go ahead and give us this pretty output that we have down here. So whenever we make a request, it'll give us all this stuff. It'll tell us where the request came from, how long it took to execute, the status code that was returned, the root, the method, etc., etc. Very useful. I highly recommend throwing this on there. Then we have recover.new. So what this will do is if any of our functions cause our server to crash, it will gracefully recover our server and restart it so that our production doesn't crash if something goes wrong. So this is very good for keeping your server secure and safe and maintaining prod, making sure prod doesn't go down. Then finally, we have cores.new. This is just going to allow us to call this from wherever we want. It will allow us to call this from a JS app. This will allow us to call this API from a JS app wherever. I don't have any special core set up. This will just allow from anywhere. So those are the basic middlewares we need. Then finally, I have this little thing called add book group. I'll get into this in a moment because this is the bulk of the app logic. And then finally, we go ahead and start our server. So I set up just this port variable. I check, okay, if we get the port, so I get the port. So then I need to get the port from the environment variables. When we go to host on Railway, they will provide us with a port number, and we need to actually we need to serve our connections to that port. So I need to make sure that this is an environment variable. For my .env, I have 8080 as my environment variable, and then my MongoDB URI is just pointing to my local database, which I have running right here. So I just spin it up in here, and then I can run it like that. So we're checking if we have port, and then if port is not equal to an empty string, then we set the port to 8080. This is backwards. I should have this actually being port equals empty string. So if the port is empty, that means we haven't set the port. Then we want to set it to a default of 8080. Otherwise, we just want to put it to whatever the port was, so that way when we get up on Railway, it will set the app to listen on the provided ports. And then finally, app.listen will start our app, and then it will block right here, so then this return will never actually happen because we'll be sitting right here. So with all that said, let's go ahead and take a look at the meat of this app, which is going to be within our router. So within our router right here, we have this book.go. I did all of this in one file. This probably could be broken up into multiple files, but for me, for this example, I thought it was pretty easy to just do it here. So what I did is the first thing I did is I defined a new group. So within Fiber, what you can do is you can define these groups, and these groups are just subdomains, not subdomains, they're like groups within your route. So if you have a group under /books, all of these roots will then be attached to /books. So this will be /books /books/ID /books/ID, etc., etc. So you get the idea. You can kind of see that on here, how our GET request is going to /books slash for the basic get request, or if we pass an ID, we now go to that. You get the idea. It's basic routing stuff. And then I just define these 5 methods, my two get methods. Yeah, these 5 methods, my 2 get, 1 post, 1 put, 1 delete, get full CRUD implementation going there. So the first one we'll talk about is get books. So this is the basic one that's just going to fetch everything. And this is going to, you're going to see a lot of just boilerplate MongoDB syntax in here. The first thing we do in here is I need to get a pointer to the actual collection. So I'm going to say collection equals common.getDB collection. The reason why I'm doing common dot here is because this package is called common. So whenever you're working with a larger Go project, this is something I didn't figure out for way too long. And the way it actually works is up here you see how I have common, I'm package common. If I ever want to use this, all I have to do is just within this thing, I just do common dot and then put in the method. And these methods have to be capitalized. The way Go does private and public scoped variables or packages or whatever is based on whether or not they're capitalized. So if I had in here made get DB collection lowercase g, get DB collection, it would not have worked. But in here, it works because I'm doing capital G get database collection, and I'm telling it I want a collection of books. And then the actual code for that inside of our database file is just up here, it's just db.collection, and then we're passing in the string name of the collection, returning a pointer. Very simple. So we get a pointer to this collection, and now we need to actually fetch the data. And the way this data fetching works is there's a lot of boilerplate for this, but it looks scarier than it actually is. So the first thing we're doing is we're creating our array of books to actually load the books into. So I'm just making a new array, initializing it to a length of 0 because I don't know how many books there are going to be. Then I go ahead and I just do collection.find. I don't pass in any arguments. Over here is where I could like put in a filter or something. We don't need to do any filters. I'm just going to say get all of them no matter what. And then I will do if error is not equal to nil, we'll return a new error. Now this is a little different because each of these, when they're returning an error, if these functions end up returning an error, that will actually throw an error to the client. So for example, if something breaks in here, this will actually, whatever we return from this function is what will be returned to the end user. So if we return c.status of 500, it'll send back a 500 to the end user. So if we have an error, throw the user an error. Then finally, we just need to go ahead and iterate over all of the books that we get. So when you do a find in MongoDB, instead of just getting back the raw data, you're going to get back a cursor. Then you can use that cursor to go ahead and actually get the data out. So what I want to do is I want to do for cursor.next and then pass in c.context. c.context is just the context of the server. You need that for your next cursor. So we pass in that context and then we do cursor.next. So when I'm saying for cursor.next, that's just saying as long as there's something within the cursor, keep going. So as long as there's something as long as cursor.next exists, we can go ahead and do this. So we're going to do book equals models.book. So this is just making a new book. And models.book, I'll show you that after I finish this method. So we make a new book. Then we go ahead and we pull out an error, and then we do cursor.decode book. So we're going to destructure everything within that cursor, load it into the book struct, and then if we get an error, we'll send back the error. Otherwise, we append that book to the books array, and then at the end here, we just send those back down with data books, and as you saw earlier, it will show just like this. So last thing I want to talk about is this model. So I have models.book, and that is coming from my models package. So I have this package models, and this is very simple. All I'm doing here is I'm just defining structs to give myself type safety and to keep track in my head like what I'm actually dealing with. I could have just made those anonymous maps and then not paid attention to what the fields are, but I like adding types to all this stuff because it makes organizing it a lot easier. So the key thing to notice here is ID, title, author, year. So very basic stuff, they're all strings, but the key over here is going to be this stuff right here. These extra features are something that Go provides, which I think is one of the best parts about the language, which makes their structs really, really strong, is I define that, okay, if we want to serialize this into JSON, I want this to be an ID. So instead of being capital ID, it's going to be lowercase ID. As you see over here, let's go ahead and run this again. So if we run this again and we make a post request and then we go and run a get request, you're going to see over here, it's being stored in the code itself as capital ID, capital title, etc., etc. But over here, it's lowercase. And that's because we're serializing JSON to send down to the end user, and we're defining how that JSON should be over here. I utilize this in Insider Viz all the time because it makes it way easier to you can manage the data however you want with whatever names you want over here, but then you can define what you want the end user to get back over here. And then this bson over here is how MongoDB handles it. So if we look at our MongoDB compass over here, and I refresh this, we're going to see in here I have title, author, and then underscore ID. And you can see how bson we have underscore ID. that's the bson is what it corresponds to in MongoDB. So in MongoDB, this is what we're going to have our fields titled by, and in JSON, this is what we're going to have them titled by, and then in code, this is what we're going to have them titled by. So it's a very useful thing you can do with these structs, and it's something that you need to get used to if you're going to write APIs in Go. So now we've done that, we loaded the book, sent it down. That's our first GET request. The next one is going to be a more specific one, and this is going to be finding one. So in this finding one, this GET book, we're going to be taking in a parameter. So first, I just get a pointer to the collection, as you always would. Then we go ahead and we get ID is c.params ID. If you remember all the way up here when we did book.get, we did :ID. :ID is saying that, okay, whatever comes after that slash, that is going to be my parameter, and the parameter name is going to be ID. Very similar to, it's exactly how Express works, which this is an Express inspired framework, which is why this should feel very familiar to you if you have any experience with that. So the ID is going to be c.params ID. Then finally, I want to check, okay, is the ID equal to nothing? So that means that they didn't pass an ID in. If that happens, I'm going to say, hey, an ID is required. I need this from you. Otherwise, we're going to go ahead and we're going to parse this into an object ID. So the reason why we can't just leave this as a string is because in MongoDB land, the IDs themselves are not actually just strings. So if you look at our entry in here within MongoDB Compass, it's actually an object ID. So we need to take this string ID and then we need to create an object ID from it. So I'm doing primitive.objectID from hex, passing in the ID. I'm getting an error out, obviously, and then this is just, you're going to see this a million times. I won't keep saying it over and over again, but it's just, if we have an error, return the error. Pretty simple. So we get our object ID out here, and then we can pass that down into our find query. So then afterwards, we need to actually create our book model that we could decode into, and then we can call collection.findOne. So instead of find, we're just going to be finding one entry. We pass in our context, which is going to be the context from the request. Then we go ahead and we pass in bson.m. The bson package is something that you can use within Go and MongoDB. It's the reason why I've said many times that the two languages work beautifully together. This bson package just works great. And the way in bson.m is a map. So I'm saying it's just a map, which is just key value pairs essentially. So my key is going to be ID and my value is going to be object ID. So that means that I'm filtering by ID of this object ID, which I've created up here. Then finally, I'm decoding whatever I get out of this into the book. And then we get our error, as you know. And then finally, we send this data down to the end user. So if we look at this right here and we do this, paste that in, and send a GET request, you can see how that would work. So we're getting that, we're filtering by this ID, turning it into an object ID, finding one out of the database, and then sending it down to the end user. And when we send it down to the end user, we're saying .json. So since we're doing the .json, it can go to our book model and say, okay, I need these fields to be JSON, and it'll send them as such. Next up, we have the create book, and this is probably the most, well, probably not true. The update one's probably more advanced, but this is the most interesting one. And I have this thing over here, and I have this create DTO. So this create DTO is defining what the shape of my input data needs to look like. So a DTO, if you're not familiar with it, is a data transfer object. It's effectively just a type of what your request body or sent or response body should look like. So I'm saying that the create DTO, so the create response body, needs to look like this. It needs to contain a title, an author, a year, and then I can utilize this struct in here to actually create the book. So what I'm going to do is I'm going to say B is new create DTO. So this is just going to initialize a new create DTO object. And I'm going to do just, I'm going to parse it. So I'm going to do if error : equals c.body parser. So I'm initializing a new error. I'm going to go ahead and parse this B. So oh yeah, sorry. No, that's not how it works. So what I'm going to do is I'm going to do c.body parser. So I'm going to take the body of C and then I'm going to parse it into B. So B is just this create DTO that I just made. So I'm going to parse it in there and then that could return an error. So if it doesn't match, it's going to throw an error. So then I'll return that and say invalid body. Otherwise, if we get that, we're going to now have a new create DTO object, which we can then use down here to actually create the book. So if you remember the structure of our data, we have title, author, year, and then an ID. We don't need to pass in the ID because MongoDB will auto-generate that for us. So we can just use these three fields and then pass them into a create. So we get our collection and then we do call.insert1, pass in the normal context, and then pass in B. So it's really easy. Once you have this done, you can just pass that the body in and then throw your error, and then otherwise we send back the new object. So to show you how that works, let's first start with it breaking. Okay, so let's first start with sending in an invalid body. So what I've done right here is I'm going to create a new book with a title of this, but then my author is now going to be of 3. So this is going to be of type number. And if we remember back within our router over here in our DTO, we're saying that our author needs to be a string. So when we pass this in, this is going to break. If I run this again, it's going to say invalid body. So what I have to do is I have to fix this to be something correct. So I'll just say real author. So then now it'll actually work. And then if we send it back, it'll actually insert it into our database. So now if we go back over here, you can just kind of see how this works. And now let's take a look at the actual update. So the update is one of the most interesting ones in here because I'm using this omit empty thing. So if you remember within these structs or whatever, I am defining what these fields are actually going to look like and how they're going to be serialized or deserialized based on JSON or BSON. And what I'm doing here is I'm saying omit empty. So that's basically saying if I don't have a title or I don't have an author or I don't have a year, omit it. So let's show you how that actually works in principle. So if I go ahead and I get all of my books, you're going to see right here I have all of this stuff, and then I can say, okay, let's update, let's do this test book updated, and then let's go say new update 2, and then let's go ahead and set real authors, but then let's not include the year. So our year should not change on this guy. Our year is currently empty. Let's just ignore that. And then we can go ahead and copy this ID. Okay, so I have this right here. Let's send this, and now it's going to modify one document. And then if we go back and we do a GET request on this guy, it's going to have all of this stuff, but our year isn't going to be updated. Then if I remove all of these fields and I just pass in a, let's just pass in a year of 20, whatever, massive year, we go ahead and we send this, and we make a put request, and we send it. We're going to update one document, and we run a GET request. We have only updated this one field. And that is because the struct that we're passing in is only going to be parsed with the fields that are not empty. So since in that last example, the author and title were empty, we only had a year. You can see this illustrated if you wanted to go through this code and you wanted to console.log b after you do all of this, you'll see that there's only the fields that are provided. So what we're doing is the same thing, parsing our body. We're getting the ID, parsing the object ID, and now we're doing a collection.update1 call. The first argument here is going to be the filter, so we're going to do it where the ID matches the object ID. Then finally, we're going to set at whatever B is. So we're just going to call the set operator on B. So since B only includes the certain fields we want it to, so in this case, when we made this request, it only included the year field. It's only going to set the year field to whatever we pass in, and it'll leave the rest of the fields untouched. Which is why, yeah. So we leave those fields untouched, catch our error, send back the result. Very simple stuff. Finally, we have the delete, probably the most straightforward of all of them. Get the ID and object ID as you've seen before, get the collection, and then finally we just have to do collection.delete1, and then pass it a filter right here, handle the error, and then pass in the result. So if we wanted to do this, we could just go in here, run a delete, deleted one document, run get, and then no documents in result. So yeah, that is a basic overview of all of the CRUD operations on this data. So hopefully that sort of made sense. I know there is a lot of boilerplate in here, and you definitely can go ahead and abstract a lot of this, but unfortunately that's just kind of how Go works. Go ends up, I love the language to death, but it does end up with a lot of boilerplate with a lot of these if error not equal to nil, especially when you're doing a lot of I/O, which you will be in web servers. So it's not always the prettiest thing to look at, but it works really well and it's absurdly fast. So now we've got all that working, I've committed all that back up to the source. Let's go ahead and actually put this in production because I think that would be it's a good way to demo this. So what I'm going to do right here is I'm going to go to my Railway dashboard and I'm going to go ahead and I'm going to create a new project. I'm going to deploy this from a Git repo and I'm going to do vmdavis419 / what did I call this? Fiber MongoDB example, perfect. We're going to deploy now, and then this is going to crash because it's going to try and load our .env and it's not going to be there. But before we do that, I'm going to need to add something to this service. So the first thing I need to do is I need to hit new, and we're going to add a new database. We're going to add a MongoDB instance. So I'm going to go ahead and spin up our MongoDB. We're going to go in here. So now that we've loaded this, I'm going to go ahead and create our database, and that's going to be Go. What did we call this again? Let me double check. I think it was Go demo. Yeah, Go demo. So we'll do Go demo, and then we're going to go ahead and pass in a collection name of just test, and then hello world. Add database. Okay, so we've created this. We have our Go demo. We have this collection which has test within it, and within here we have this document. Makes a lot of sense. Pretty simple. This is just a document database. So now that we have this actually working, let's go ahead and get our connection string. Okay, so I have this connection string right here. I can't show you what this connection string is. Actually, I probably can't because I'm going to delete this before I put this up anyway. So you have this connection string right here. We're going to go ahead and copy this, and then we're going to go into our Fiber Mongo example, and we need to set up our variables. So we're going to first make a variable which is going to be prod, and we're going to set this to be true because we don't need to load our .env. Then I'm going to add MongoDB URI, and then that's going to be what we just had there. Paste that in, and then finally I'm going to go to settings, and I'm going to generate a domain on this guy, and now we can go ahead, and I think that's it. Okay, so that works. So all we need to do now is we can just go to this real quick, and then if we do /books, it will give us an empty data array. So we copy paste this back down into our little HTTP client. We can send this. There's not going to be anything in here, but if we want to go ahead and post to this, we're going to go ahead and add an title. We're going to say prod book. We're going to set author. It's going to be me. And then our year is going to be 2022. So now we can go ahead and run this. We make a post request, inserted a new document. We go ahead and get this. And now we have a document in here. And all of the CRUD implementation we did is now working. So we can do this. Let's do a get real quick. So we run that. We get this one specific book. Keep running it. It just works. Now we can go ahead and run a put request on this. So let's change our year to 2023. Let's say I did this. And then let's say prod book 2. We send this. We've updated one document. Run a get request. Everything's updated. Finally, we can run a delete. Hit the delete button. Get. It'll not found. And empty array. So there you have it. We have a full CRUD app out in production. This took what? Oh, a half hour. Okay. So it took about a half hour to go over all of that, but it works. That's it. So that hopefully gives you a good idea of how to actually use this. All of this code is going to be in the description. Public, open source. Use whatever you want out of here. This is a basic CRUD example. And yeah, hopefully this helped you out, and have a great day.